What is dark energy? Try to imagine the entire universe, a vast expanse stretching in all directions, filled with galaxies, stars, planets, and unimaginable distances. Now consider this. Everything we can see, everything made of atoms, from the smallest grain of sand to the largest galaxy, makes up less than 5% of the universe. The rest? That's where things get interesting. For most of history, scientists believed gravity was the main force shaping the universe, tugging everything together, slowing cosmic expansion. But in the late 1990s, something strange was discovered, something that changed our understanding of the cosmos forever. Two teams of astronomers were studying distant Type Ia supernovae, stellar explosions so bright they can be seen across billions of light years. These supernovae serve as standard candles, objects whose true brightness is known, allowing us to measure their actual distance from Earth with surprising accuracy. When these researchers looked at supernovae in distant galaxies, they expected to see evidence that the universe's expansion was either slowing down due to gravity or coasting along at a steady rate. Instead, what they observed was the opposite. Distant galaxies were speeding up, accelerating away from us at a faster and faster rate. The universe wasn't just expanding, it was expanding faster the farther away you looked. This was not supposed to happen. Gravity, after all, is attractive. So what invisible force was pushing galaxies apart, stretching the fabric of the universe itself? Scientists called this enigmatic force dark energy. But what precisely is dark energy? Even today, more than 20 years after its discovery, no one knows for sure. Here's what we do know. Dark energy is not something we can see, touch, or directly measure. It doesn't shine, reflect, absorb, or block light. It has no color, sound, or taste. Yet its influence is enormous. Based on observations, dark energy accounts for roughly 68% of the total energy content of the universe. It is not even a minor detail. It is the main ingredient shaping the universe's fate. One way to think about dark energy is to imagine space as a stretchy fabric. Traditional matter, and even dark matter, the mysterious stuff holding galaxies together, puts dents and curves in this fabric, creating gravity. Dark energy, by contrast, seems to act everywhere, at every point in space, pushing it apart, making more space as time goes on. But what could possibly cause this effect? The most widely accepted idea is that dark energy is really just a property of space itself. Einstein first hinted at this notion with his cosmological constant, a mathematical tweak he added to his famous equations of general relativity. At the time, he introduced it simply to balance gravity and keep the universe static, not realizing the universe was expanding. When expansion was discovered, he reportedly called the cosmological constant his biggest blunder. But with dark energy, his idea is back in play. According to this idea, empty space isn't really empty. It has some intrinsic energy. As space expands, more of this energy appears, driving further acceleration and so on. But there are other ideas as well. Some physicists have proposed that dark energy could be a dynamic field, changing in strength over time, a concept known as quintessence, after the ancient idea of a fifth element making up the heavens. Other more speculative theories suggest that our understanding of gravity itself might be incomplete on cosmic scales. If gravity behaves differently across enormous distances, it could create the illusion of dark energy, even if no actual energy field is present. What's remarkable is how little direct evidence we have. We can see the consequences of dark energy, galaxies racing away from one another, patterns in the cosmic microwave background, the distribution of galaxy clusters, but we can't pin down what dark energy is, where it comes from, or even if it's truly a single phenomenon. Physicists and astronomers are working hard to solve the puzzle. Space telescopes and massive surveys scan deep space, mapping galaxies and supernovae to trace the universe's expansion history. New missions like the Euclid and Nancy Grace Roman space telescopes are designed specifically to probe the nature of dark energy. In the end, dark energy remains one of the greatest mysteries in science, telling us that there's still so much we don't understand about the cosmos. It pushes the boundaries of physics, hinting at hidden dimensions, new forces, or perhaps a deeper underlying order beneath reality's surface. So the next time you look up at the night sky, remember, the universe is held together and pushed apart by forces we're only just beginning to uncover. Dark energy is the invisible architect of cosmic destiny, and its true nature may change our picture of everything we know.